Hello everybody, and welcome to your linear algebra review on finding the inverse of a 2x2 matrix. My name is Jason, and I work for the ASU Tutoring Centers. Now, if you didn't watch the previous video on showing two matrices are inverses of each other, I definitely recommend checking that out. In that video, I went sort of in depth on what an inverse is and what are some properties of inverses that we know. But just as a reminder, so say you have some arbitrary matrix, A, so I'm just going to call A, some matrix. If it's invertible, so if it has an inverse, we denote that inverse by A with a little -1 in the superscript. So this is the inverse of A. And the special property of the inverse is that if I take my matrix A and I multiply by A inverse, or if I do it the other way around, if I take A inverse and multiply by A, out will spit the identity matrix. The identity which has just ones on the diagonal and zeros everywhere else. Right. So that's what the inverse of a matrix is. And as I mentioned in the previous video, not all matrices are invertible. In fact, only square matrices are invertible. And even then, not all square matrices are invertible. So not every matrix is an inverse. And in the future, we'll discuss about how do you show a matrix has an inverse. Well, one way you can do it is actually by finding the inverse. Right? If you're able to find the inverse, then your matrix must be invertible. So the process to find the inverse, what you do is you take A and you augment A with the identity matrix. So you put A into a matrix, augment, you put the identity matrix in there. And then what you do with this system is you reduced row echelon form it. So you do all your row operations to get it in reduced row echelon form. Now, if your matrix A is invertible, what will happen is the left-hand side will become the identity. So if you don't get the identity on the left-hand side, either you messed up somewhere along the process or your matrix just isn't invertible, but it should be the identity. You shouldn't have anything weird going on. It should be exactly the identity. And on the right-hand side, you'll get A inverse. So you can explicitly find A inverse using this method. And there are other methods that you'll learn in the future once you learn about the determinant of a matrix. But this method works for all matrices, okay? If you want to check if a square matrix is invertible, toss it into a matrix, augment with the identity, reduce row echelon form that. On the left-hand side, if you get the identity, then you know it's invertible. And in fact, you know what the inverse is. It's whatever's on the right-hand side. Okay, so let's see this in action. Let's apply this here. So I'm trying to find the inverse of B. So what I'm going to do is I'm going to take my B matrix, and I'm going to augment with the identity matrix. And now my goal is to reduce row echelon form. So let's remember reduce row echelon form. First thing you want to do is get a 1 here, which we already have, so that's nice. Next step is we want to get this to be a 0. So if we take row 2 minus 2 row 1s, let's see what happens. So the first row is not changing. The second row, so we're doing 2 minus 2 of that. 2 times 1 is 2, 2 minus 2 is 0. Okay. Then we're doing 0 minus 2 of those. So 2 times -5 is -10. 0 minus -10 becomes +10. Then we're taking 0 minus 2 of those. 2 times 1 is 2, 0 minus 2 is -2. And then we're taking 1 minus 2 of those. 2 times 0 is 0, 1 minus 0 is 1. Okay, so this is our first step. Next step, get this to be a 1, correct? So let me go ahead and erase that. So I want that to become a 1. That means I'm just going to multiply by 1/10. So I have 1, -5, augment with 1, 0. I have 0, 1, -1/5, and 1/10. Last step, I want to get this guy to be a 0. So I'm going to take row 1 plus 5 row 2s. So over here, I'm going to end up getting the identity. My second row is not being affected. And my top row, I end up getting 1 plus 5 of those. So 5 times -1/5 is -1. 1 plus -1 is 0. Then I have 0 plus 5 times 1/10. 5 times 1/10 is 1/2. 0 plus that is 1/2. So I got the identity on this side, which means this guy is my inverse. So B inverse is 0 1/2, -1/5, and 1/10. And in fact, we can verify that that is our inverse. Let me clear out a little space. So how do we verify that that is our inverse? Well, if we multiply it by our matrix B, we should get the identity out of it, right? So let's see that in action. B times B inverse, 1, -5, 2, 0, times 0, 1/2, -1/5, and 1/10. So let's do the multiplication. So we're going to take our first row times this column. So 1 times 0 is 0. -5 times -1/5 is 1. 0 plus 1 is 1. Then we multiply by our second column. 1 times 1/2 is 1/2. -5 times 1/10 is -1/2. 1 plus -1/2. I'm sorry, 1/2 plus -1/2, 0. Then we go to our next row and we repeat the process. 2 times 0 is 0. 0 times -1/5 is 0. So that gives us 0. And then we multiply that second row by our second column. 2 times 1/2 is 1. 0 times 1/10 is 0. We get 1. So when we multiply B by B inverse, we got the identity, which is what we should have gotten. So yes, in fact, this is our inverse to our matrix. Pretty cool. And remember, that process of taking your matrix, augmenting with the identity, and RREFing it, that works for any sized matrix you have, any sized square matrix. So you can have a 2 by 2, 3 by 3, an 87 by an 87. Doesn't matter. It'll work. Cool. So thank you for joining me on this fun adventure through linear algebra. As I mentioned at the beginning of this session, I work for the tutoring centers. If you want more information about the free resources we offer on all 4 campuses and online, please check out tutoring.asu.edu. If you want more videos like this one that go over specific concepts from your course, or maybe you want to see what upcoming review sessions we have for your exams, go ahead and check out this link down there. Again, thank you for joining me and have a wonderful, wonderful day.